Okay, so now let's carry on. We are at page 3 and 4. The video will focus on the MCQs. So it is more general. The MCQ is on a more general questions about kinematics. So it's like whether you can classify it between vector versus scalar, or whether you can read the graph, how you are going to interpret the graph, things like that. So let's begin. Which quantity is vector? I think by now you should know that distance is a scalar, time is a scalar, volume is a scalar, because if you look at B, C and D, all of these are involving only positive number. You can't have negative time. Time does not travel backwards. Volume, there's only positive volume. The smallest you can get is 0 volume. Like I said, distance, you can only increase in distance. Yeah, so because of that, acceleration is the only one that is a vector. It involves directions. If you look at 9, I think the question wants you to calculate acceleration. So maybe it's time for us to recap on what is the meaning of acceleration. Basically, acceleration is just the change of velocity over unit time. So down here, we were told that the car is accelerating from this. So just beware, these two numbers are not acceleration. As you can see from the unit, they are actually the unit of speed or velocity. So basically they are telling you that at the very beginning, that is the starting speed, it was 20 meters per second, and that the final speed v is 30 meters per second. So they are saying that during this acceleration, the car actually moved 100 meters, and that the average speed is 25 meters per second. So just one look, I can actually tell you that this particular question is not easy, because you would need to mentally sketch your speed time graph or your VT graph. So down here, what happened is that if you start the time from 0, the speed will actually start from 20, because this is your initial speed, right? Then the question is saying after some time, you do not know what time it is, so let's call it t. After some time, the speed would actually increase to maybe 30. So you will end up with a graph that looks like this black line. And you can see that there are some unknowns, like for example, this t over here. But what we know is that during this acceleration, the car actually moved 100. So in order to find what is this time, we need to know how long it takes to increase my speed from 20 to 30, right? I need to make use of this distance, and the distance traveled is actually given by the area under the graph. So if I look at this, then I need to make use of my area formula, which is going to be half a plus b times h. So this is actually the what do you call that, trapezium area. So a refer to here, and b refers to here. So if we substitute the values in, I will get half 20 plus 30 times h. So what is h? In this case, h will be here, which is the unknown t, because this length is t minus 0. So that's how I got it. And we know this area is going to represent the distance, which is 100. Okay, so by doing this, I would be able to solve my equation. So this would be 4. So now I know that t is 4, and the question actually wants me to solve for the acceleration. So now I can solve for it. So v is 30, the final speed, u is 20, and then down here I just need a 4 underneath, and then I could actually find this. So 30 minus 20 is 10 over 4, and I would get 2.25, I guess. 2.5, yeah. So I will get 2.5. Now on second thought, I realized that I have not used this value, and I realized that actually I do not need to draw a graph like that to sketch you off. I can actually make use of average speed. So I can actually have plan B. I will use my average speed, which is equals to distance over time, right? So my average speed is 25, my distance travel is 100, and then I want to find the time. So if I do that, I could actually find the time as well using this method rather than drawing a graph. So 100 divided by 25, let me get my calculator, it would be 4. So as you can see here, by using the average speed method, I can get time equals to 4, or I can use the area under the graph, I would still get 4. So both methods will give you the same time, and you can use the time to actually solve your acceleration formula, solve for your acceleration. Okay, next question, I'm given a special graph. It is the acceleration height graph. So it is different from our normal kinematic. It basically also checks whether you understand what is meant by free fall. So in another word, free fall means that the only force acting on it is the weight. Weight is the only force. So if you are good with your forces, if weight is the only force, and you apply the formula F net equals to ma, whereby F net is the sum of forces, and in this case there's only one force, which is the weight, then your weight is equals to mg. So you can see how I develop my equation. I will do left hand side, slowly develop downwards. Okay, and then the right hand side, if I can't do much, I will just keep writing the same thing. So at the final step, you can see that the m is on both sides, and you can actually find out that your acceleration is always g. So what is g? G is basically 10 on Earth. So as you can see here, if we are undergoing free fall, that means the weight is the only force. By using Newton's law, I can actually derive and find out that my acceleration is always 10. So meaning that no matter where my object is, whether it is at very high ground or at very low ground, my force is always the same. So for example, let's say I drop the thing from this building. At the top of the building, I will get the only force is weight, so A is 10. If it is approaching the floor, the only force is still the weight. So the whole mathematical expression is still the same. So A is 10. So because of that, if you have this knowledge, then you will be able to interpret and say that, oh, my acceleration, which is this, my acceleration is going to be always 10, no matter where you are at along their height. So the answer is A. So I would say that this is a rather difficult question. Maybe some of the combined science may also not be able to answer. So in summary, if you have an object that is going through free fall, okay, if you are undergoing through free fall, the acceleration is always g, regardless of your mass, regardless of the height or the position of your object. So just remember that. Okay, let's go to the next page. So for the structure question, we will go through in class. Like I said, the video will only cover the MCQ. So let's look at this. I have an object that is near the surface of the Earth, and it is acted upon by a constant gravitational force. So what is this weird long name called constant gravitational force? It means it is the weight. And very quickly, you should have in your mind the formula for the weight, which is mass times gravitational strength. So now I have to give an approximate of the initial rate of change of velocity. So again, they are throwing in some big words. What is rate of change of velocity? Basically, rate of change of velocity, this entire word is just your acceleration. So they want you to find an acceleration of an object undergoing free fall. So at the beginning of this video, or I would say the middle of the question, I have already given you, right, any object that is undergoing free fall will have an acceleration equals to g, which is 10. Okay, g is 10 on Earth. So this a equals to g is regardless of what mass you have, is regardless of what position the object is. So down here, if you want to find the acceleration of an object undergoing free fall, it has to be 10, because that is the gravitational acceleration on Earth. So I have 10 here, I have 10 here, I have 1 which is wrong, 1 which is wrong. So be careful with your unit. Okay, this meter per second is speed. That is not what we want. Okay, we want acceleration. So therefore the answer is D. Meter per second square is the unit for your gravitational acceleration.